Thank you. Okay, thank you for coming to our webinar. It's January 25th, 2012. This webinar will be on ASCII strings. Again, my name is Anthony. We're here in our Quincy office, Unitronics. I have Ryan here as well, and he'll be answering questions if you have any, so please feel free to ask as we go along. This is an interactive webinar. We will have the webinar posted up on the web like we usually do, and the video will be on YouTube, and the links will be on our website. So if you want to check them out, please do that. If you want to check out the rest of them, www.unitronics.com/webinars. And again, if you have any recommendations or requests for future webinars, please send us an email at support@unitronics.com. Okay, so to get started today, again, we're going to be talking about ASCII strings and the tools we have available and how we work with ASCII strings on our systems. Okay. We'll go over a quick overview here. So, of course, we'll be talking about ASCII strings, how we store them. We're going to look at a couple function blocks, how we convert ASCIIs to numbers, numbers to ASCII. We're going to look at searching and parsing strings and building custom strings. This is very useful for a number of our function blocks we have available for communication and for data logging. If you remember from data tables, we use the RTC to ASCII function to convert the time into a string to save it in our data table. For email, for SMS, protocol communication function blocks, we can build custom messages. So if we want to say the temperature is 300 degrees, we can format that as an email or an SMS and send it that way. As well for displaying information on the HMI. The ability to build a custom string means we can basically display any number or character configuration we want. Okay, so let's get started. Let's talk about, whoops, I'm sorry. Let's talk about what strings are. If you remember from our vector description in our previous webinar, we can store things in memory integers. We're specifically going to be storing numbers based on the ASCII code. This is a quick picture of the ASCII code. You notice that there's a description here for decimal and one for character. Every character can be stored as a number. If we look down at 0 to begin with, you'll notice that there's an ASCII conversion for each variable. We're going to store these pieces of information in memory integers, memory longs, or in double words in our system. So we'll come back to this map, but let's take a look at the next slide. One ASCII character is 1 byte. And if we remember how big a memory integer is, 2 bytes, we're going to store 2 ASCII characters per memory integer. We can also store, as I said, ASCII strings in memory longs or in double words. You see on the bottom here there would be 4 bytes, so we can store 4 characters per memory long or memory integer. The properties of an ASCII string again, they're stored in vectors, and we're going to store what's called a null character at the end of every string. Our ASCII tools, as we'll see, are set up to read natively these vectors and convert the ASCII characters. I'm sorry, the numbers to ASCII characters. Here's a shot of VisiLogic and the strings function blocks. We'll go through a number of these. Okay, so I have prepared a project on the V570 that we'll look at here. Again, this project will be available on our website afterwards. So I'm going to bring up the online view, and we'll talk about a couple things. But first, on the main display I have here, we're going to look at how we enter an ASCII string from the HMI. Again, I'm using a V570. I've set a variable here of the ASCII string type, and we see under text our ASCII string variable here. the properties we have for this variable are the start of vector. And again, we'll see this in a second after we enter a string, but we have to give the string a start of vector and some length for where we can store the rest of the information. The number of characters we define here are the maximum number of characters we expect to store in the string. In this case, 30 characters. Again, when we mention we store a null at the end of the ASCII string, this is to indicate the end of the information. This is very nice because we can use one memory location to store a string of varying length. If we want to store names, for example, if we have a relatively short name like Mike, it's going to be 4 characters, and then we'll store a null after it. If we have a longer name like Anthony, it's going to be 7 characters, and we'll store a null after it. We can use the same memory location and overwrite and not have to worry about reading the rest of the information past what we're interested in, because the tools will stop at the null. Okay. Again, to make this a keypad entry variable, we've selected keypad entry here. And of course, when we're working with ASCII strings, we have to select a link bit. What this link bit does is when it's pulsed, it refreshes the HMI at the same moment that we've entered the data. So if we enter a new piece of information to the ASCII string, we can pulse this link bit and we'll refresh the HMI. In the enhanced series controllers, they do update faster than the standard 120 and 200 series, but if we notice any lag and we want to update the screen right away, we can pulse this refresh bit, and we'll see that in a bit. Okay. So I'm going to hit OK here. Again, this is how we've set up our ASCII string entry on the HMI. I've set up 3 function blocks here. This is a left portion of string function block, a right portion of string, and a middle portion of string. What we're going to do is type in information here. We're going to select the number of characters that we want to copy, and the information that we've copied will be displayed in the second string here. So if we take a look here, it's MI200. Again, the same number of character length, although we should assume that it can't be any longer than the first string we've entered. And again, a refresh bit here, but notice no keypad entry. This is going to be the result of the function blocks here. Okay. So what I want to do is go online with this, and we'll take a look at it working, and then we'll look at the code behind it. So I'm just going to select our online view, and I'll select the controller view option, and I'll make it a little bigger so we can all see it. Okay, so we type a message in the top, hello, everyone. Okay, so we have a slightly longer message here. We notice we have the number 4 entered. This is a parameter that we'll see. This is the number of characters from the left side of the string that we want to take. So what we're doing is parsing out information here. If I press the left button, notice we've ended up with hell. If I put in another value like 8, notice we've taken the 8 characters from the end. And it's very important to notice that we've taken the space as well. So the space is an ASCII character. And if you give me 1 sec, I want to pull up the ASCII table again. Again, what we see here is the character description and the decimal hex and oct representations. And we notice that the space is also an ASCII character here. Okay, so it's decimal 32 as a space. And we'll see that when we look at the string in the memory integers. Okay. So right, again, we can select another number. We'll say 3 and press the right key. And notice we've taken the end of the string, 3 characters. And we have a middle option here. The way the middle function works is that we enter a starting location, again, which character from the left, and the length that we want to take. So right now, with 2 and 2, if I press middle button, we're going to take the L and the L. Okay. Now it's important to notice that we put in 2 here. If we count out 1 and 2, we expect to start at the E. Actually, we're starting with the first character is 0. Okay, so it's 2, H included as a 0 from the beginning with a length of 2. So let's change this parameter, and we'll make it 5, and we'll hit middle, and we'll see what we take. Okay. So these are some basic string tools that allow us to do some operations. Okay, so let's look at the logic behind these. If we go to our main routine, I've set up 3 subroutines that we can take a look at. Notice that MB1, 2, and 3 are the buttons that we had on the HMI. They're each going to run these subroutines one time when we press the button, a positive transition. Okay, so let's look at the left string. What we see here is the string left function block. Again, we have our input, which is MI100, which is the address of the start of the string. We have the number of characters we want to take. Again, since it's string left, it's starting at the left side of the string. And we have the destination of the string that we want to save the information to. Again, MI200 was the string on the bottom that we saw there. Okay? And after we perform this operation, we're going to refresh this screen. MB0 is HMI refresh bit. We saw a link to that ASCII display. Okay. So, you notice that looking at MI100 and MI200, we have the number 17,736 and 19,532. This does not look like the message start of hello, and this does not look like the character, the letters LL, but these are in the ASCII code. Okay? And again, if we want to look at our chart, the capital letter H is a 72, the capital letter E is a 96. We're storing, as we said, 2 bytes per memory integer. And again, each character is a byte. Memory integer is 2 bytes, or 16 bits. But we're storing them as decimal values in this case. So we're going to view them as decimal values. So what we have here is the high and the low byte of a memory integer. Now we've got a very nice tool called memory, and it allows us to display strings and vectors of a length up to 32, of various size. We can see what we can select: 8, 16, 32. Okay, so 8-bit, again, this is giving us a single character. 16-bit would be the entire memory integer. 32 would be an entire long or double word. And we can select on the right side the format. And we've selected ASCII string here, and we can see that we have our input MI100, hello everyone, and our output MI200, which is the result of the function. Now let's go ahead and we'll press the left button. I'm going to press it on the HMI again. Notice when we press the left button, I'm just going to jump back to the main routine. We're going to run this subroutine one time. Okay, so let's look at left string. And now you might have questioned why we put these function blocks directly to the rail. Wouldn't they activate all the time over and over? Well, since we called them from the main routine with this positive transition contact, they're going to run just once when we press the button. Okay, this is a very nice property we can exploit here about the positive transition running a subroutine. It allows us to build functional code and not have to worry about it looping over and over again. In fact, we can put lists of items here and just process them one by one and not worry about it looping around. Okay, and we'll see that when we look at the parsing string in a bit. Okay. But let's go ahead and we'll change this format from ASCII to decimal. And we see now we have characters here: 69, 72, 76, 76. Let's go ahead and let's take a look at that table again. If we look up the decimal side, 69 was our E. Oops, I'm sorry, I highlighted it. And our L is down here at 76. Okay. It looks backwards because the high and low byte are flipped. Again, ASCII code is not the easiest thing to read, but we have a very nice tool that converts it for us. And again, if we want to see this as hex, which is also very handy sometimes, 48 and 45, we can go back to our table. Let me see under the hex column, our 48 is the H and our 45 is the E. Okay. So these are the beginnings of our strings. Now we put it back to decimal one more time, and we'll notice that what we see now is that each of these strings ends at 0. We have other information here. If I go ahead and store a smaller string, we'll just put the letter F. It's cleared everything out. And again, we're seeing the high and low bytes swapped, but the strings are going to stop at the 0. So if we didn't have a function like the keypad entry that stores and clears out the vector, as soon as we see this null after our string, the string tools will know to stop reading strings. So they work very nice that way. I'll put this back to ASCII. Now we'll take a second and just drop down the strings functions here. Again, we're using the left part of string. We're going to look now at the right part and middle part. But in general, this is where we find our string functions. Notice to the left are vector functions. We don't want to confuse these two. Let me just define again. A vector is a memory address with a start address and a length. So if we say a vector of memory integers starting at MI5 with length 5, we'll be talking about memory integer 5, 6, 7, 8, and 9. Now the difference between a vector and a string is a vector that contains ASCII data representations. So a string, again, is a vector, but each of the memory integers, memory longs, or double words, are going to contain information that represents an actual ASCII string. So the information we have inside the vector defines the fact that it's an ASCII string. And when we talk about length in a vector, we're going to talk about number of memory integers. When we talk about length and position in strings, we're going to talk about the characters specifically. So again, if we have 4 memory integers, we have the potential to have up to 8 ASCII characters in it. Okay. So again, I just need to point out memory integers are 2 bytes. They each store 2 ASCII characters, or can potentially store 2 ASCII characters. If we have a string with 5 characters, we should expect also that the 6th character will be a null. So we do need to take into account that we need to store this last character. Okay. And one other thing I'd like to mention is, again, when we're working with vectors, we're working with strings, when we give them names, let me go to my operands over here. Oh. I apologize, I'm bear with me one second. Let me just restart my program here. And again, strings are useful for a number of things, specifically because we have so many tools. We can manipulate them to basically look like anything we want to. We can take real information, like pressure or temperature. We can take some descriptions that we've already decided and preset. We can combine them into a message. We can send this out, again, over some communication option. Okay, now let's take a look at the next one, the right string here. I'm sorry. Let me go back to memory integers and just again show that when we're giving names and descriptions to strings and vectors, we want to make sure that we've included in the description a piece of information. Now notice again our input was MI100. MI100 is ASCII input string 1 of 16. Again, we've set the input as 30 characters. We want to take account for that null. So we need at least 16 registers, 16 memory integers to store that information. Now if you're familiar with the tool we have, the Get Next Unused Address tool, you know that we can press this button and we'll get the next unused address. We don't want to overwrite the middle of the string. That would end up putting garbage information in the middle of our string, and we don't want to do that. We need to reserve this memory space so we can store a string that can be read from beginning to end, or from beginning to null. And I seem to have locked up here again. I apologize. Give me one more second. Does anyone have any questions so far on anything we've talked about? No, as we're going through too, if you can imagine things that strings would be useful for in your programs, you can ask Ryan on specifics and he can answer your questions for you. Okay, and again, let's take a look at the right side. And again, same idea with this function block. The input is 100. The length now is 3. And so MI200, when I press the right button, should hold 3 characters. Oh, but the string isn't even 3 characters, so. Okay, so I've entered hello world. We press the right button, and we see we have these 3 characters. Okay, now let's take a look at the middle string, which is a little different. Again, we have our input and our output. And we're working with the same memory locations, but now we have a value which is the offset from the left side of the string and the length. So we've called it 2 from the left and the length of 5. So if I press middle, we see our string below here, hello world. Now, again, this memory function is very, very helpful when you're working with ASCII strings. It allows us to view exactly what's in the memory when we're online with the controller. Okay. So let's take a look at our next function. I'm going to go to my second screen here. Now, this is a function that allows us to join 2 strings. If I put in the top here, my name is, notice I'm leaving a space because we're going to join the string directly behind it. And type in Anthony. Okay, and I'll press the join string button, and we now have a string that reads my name is Anthony. Okay, so we've taken 2 separate string informations and we've joined them together. So using this function, we can build a message or a string that basically contains anything we want. And we'll come back to this one, but let's take a look at the middle string, the join strings. And again, I've got the positive transition at MB5, running the join string subroutine. Okay. Now this function block here is insert string to string. I've got our start string MI300 and our second string MI400. And we're going to insert MI300 right in front of MI400 and save it to MI500. Again, we see in our memory view, MI300 is my name is, MI400 is Anthony, and MI500 is the resultant my name is Anthony string. Now this is a very simple example. It shows how this one function works to join 2 strings. But you can think about the more complicated uses we can have. If we've got many different strings, we can use many of these to build a more complex message based on some logic. Say we have a memory bit, and if it's high, we can have a message that says the door is open. If it's low, we can have a message that says the door is closed. We can build that into a message, a piece of information that might be important to send out to the general manager of the plant over either email or SMS. And as a communication example, I've set up our protocol function block. Let me just bring up the screen again. Okay, let me just clear this away. Now we've also done a webinar on the protocol function block, and we won't go into it too in depth, but we'll talk about it a little bit. I've got a send button here on the screen. I notice we've sent to this Hercules serial terminal. This is listening on the COM port of my computer. The string, my name is Anthony. Okay, so very easy. We've built a string here on the left side from two separate strings. We press the send button, and the message gets sent over COM2 using the protocol function block. Again, I'm doing this over serial, but you can do it over Ethernet. You can do it with the email function block. You can do it with SMS. We have a number of functions that enable you to use indirect strings, as well as functions that allow you to use indirect strings to name files, like the CSV file and the SD tools. So the ability to build a string based on any information you have in the system is very helpful and very powerful. We can take a look at this function block real quick. And again, we do have a webinar on FB protocol, but I've set up in the top here our COM2 and our FB protocol. We're talking on COM2 and 9600 baud rate, 8N1, and we've set this up on COM2. And now our send function block, we've just added one variable as an indirect stream. Our resultant message was stored to MI500. Our vector length we want to define as the longest vector that could possibly be stored. And again, let's go ahead and stop reading at the null. So after the join string function block stored the message, the ASCII string to MI500, it stored a null. And since this is an indirect function, it's going to read from MI500 till that null, and we're only going to send the relevant amount of characters. Now, if you're using this function, a very important selection here is convert one linked element to 2 send bytes. It's possible to store one element to one memory integer, but if we think about our format of our ASCII string, that means the other byte is going to be a 0 or null. So really the only thing we'll be able to do is send the first character with this option. We want to make sure that we have 2 send bytes selected. Okay, and it's as easy as that to set this up. Of course, we can add a start of text and end of text. We'll take a look at that in the receive function. But again, we have a webinar on protocol you can check out, and we'll go over this more in depth. So the second portion of this protocol I want to look at is the protocol scan function. I'm sorry, give me 1 second. Okay, are there any questions so far before we go on to this receive function? Okay, so one other nice thing that we can use our ASCII strings for is the ability to parse out an incoming ASCII string. Now, I'm going to show you an example string I have here. This string is, again, it's just an example. It comes based off of something that I've seen from another customer for a device that is sending temperature values to the controller with this format. And now this is not a terribly inclusive example, but it shows the basics of how we would decode an ASCII string and store it as a number in a memory integer in the system. This protocol contains a start of text, which is a question mark, the information temp, and then within these brackets you see the numbers that would represent a temperature. Again, this is an example. A different protocol might have a different start of text and end of text. I'm sorry, let me mention as well, the end of text is a carriage return here. But what we want to do is take this ASCII string as it comes in, look for the locations of the brackets, copy the information between the brackets, and convert it to a memory integer so we can use it in our system. Okay. So let me show you our next screen. Okay, let me open our Hercules terminal again. Let's just clear out the message that's in there. Now, I've put our message in terms of the protocol we have below here. If I press send, you notice the message temp with a 9, a 99, and a 999 is converted into 3 memory integers. This is the ASCII string we send it, and these are the memory integers that we use our function to extract them to. I can send it this number. Okay. Okay. And again, this is a quick example. In actual practice, we might include some other things, specifically looking at this temp and ensuring that we've received values that are in the correct range. But again, as a simple exercise, we're going to see how we search this ASCII string for the 2 brackets and pull out the information between them. So let's go ahead and look at that subroutine now. And again, our protocol scan function block, if we're familiar with it, remember that it has a session complete bit. When receiving a message that fits the criteria of the defined message, the session complete bit will go high. In this case, we're going to run a subroutine. Before we look at the subroutine, let's look at how we've defined our message receive. Again, the function block protocol will go over this more in depth, but if we remember from our protocol, let me just put this here, we have a starter text of a question mark, a message body with variable length, and a end of text, which is a carriage return in this case. So we've defined in starter text with a length 1, 3F. In hex is, of course, our question mark. Our end of text, bring that back up, I'm sorry, is our carriage return, and we've defined that here as hex OD. And we've defined our actual message as a stream. Now, we didn't use the function num, and again, one of the nice things about this option is that it's very hard to define ASCII strings that contain numerous varying lengths. The one way to get around that is just to accept everything and then to convert it once you've got it. So with this option, if we have messages where the numbers could be anywhere between 1 and 10 characters, say, it's hard to define all these specifics because the function block scan really wants to see specific lengths or specific pieces of information. We've gone ahead and we've just selected everything from the scan, and we're going to search for the defining characters. Again, in this case, I'm sorry, I opened the wrong one. In this case, it's our square brackets. So again, we're going to search when we receive a message, and since we've defined such a broad message, the message is anything that has a length under 30 and the start and end of text. We're going to accept anything and search for the information between these brackets. And in this case, it's just 3, but we can, of course, expand it to more if the message defined required it. Again, you notice that vector length is the longest vector we might possibly accept. We have 2 received bytes linked to 1 element. Again, we want to store 2 characters per MI. And notice that we've selected the add null to the end of the stream. Now, this is very important because this is one of those tools that won't just erase the vector that it's linked to. All it knows is MI600 is where to start putting the information. Keep writing till we get to the end of the string, or we've reached the vector length, and add the null at the end. So if we had another tool that was looking at the string and we didn't put the null at the end, it would keep reading previous information in, and it would essentially just be garbage. It would be remnants from the last message. So always include this null if you're going to follow this method. Okay, with that said, let's take a look at the parse input. Now it's a little complicated, and we'll talk about it. But basically, again, if we remember what we're trying to do, we're going to receive a string. The session complete bit will go high, and then run the subroutine once. And again, since we're running the subroutine once, we're free to build the structure of the routine in a way that we're not worried about it. Sorry, we're not worried about the scan looping over. Okay. So the first thing we're going to do is search for this first left bracket. The second thing we're going to do is search for this right bracket. We're then going to find the length of the information between it. We're going to copy it to another location, and we're going to perform a function which is convert the ASCII string to a number. Okay. Now this is a little complicated, and I'm going to go over it. Each of these functions is fairly simple to use by themselves, and the whole idea, I think, is kind of straightforward. But there is room to make mistakes. And again, the easiest way to work with these functions, especially ASCII strings, is to use this memory view below here. Okay. And I do apologize for lack of comments. I will add a lot more detail in this before we put it up online. Okay, so the functions we have here first are a find string function. Notice we've put in MI600 as our starter string. We are going to search for a character that is this left bracket, and you notice the contents of this MI599 or 91. Take a look at our ASCII table. Our 91 here is our left bracket. 93 is our right bracket. Okay. So we're going to search for the location of the first left bracket. Now the string find tool has a couple interesting inputs. Again, first is of course the location of the start of the string. We're going to link here in MI599 the character we're searching for. I'm sorry, I seem to have locked up my VisiLogic again. I'm sorry, give me one more second. Again, this function is very nice when we don't exactly know the protocol we're working with. If we had a protocol defined that said specifically it's going to be 5 characters, it's going to start with this character, and the last character will always be will be this carriage return value. It'd be very easy to work with, and we wouldn't need to define this. But what these tools are allowing us to do is to accept anything that a message that fits a lot of different descriptions. If we know the information that's going to contain the the values that we're interested in, we can then build a system that will be able to accept everything. Okay, I apologize for that. Let me open that back up one more time. So that was the parse input. Okay, so again, our first function block, the starter string, the piece of information we're looking for. So I've just put in MI599 with the startup value, the value 91. And again, decimal value 91 is our left bracket. And now what's important is to make sure we understand what we're doing with this value, which is the offset. And the offset is the number of characters from the start of the string. So we're looking for, in this case, at the very beginning of the message, we're going to try and find the first two brackets. So the first bracket, we don't have to include any offset. We're looking just for that first piece of information. When we find it, we're going to store the location of the first bracket in MI630. We're going to do the same for the right bracket. Notice the difference. Instead of 91, we're searching for the value 93. Again, we can give the offset 0. And we store it in 631. So now we've got the location of two brackets. What we want to do now is copy this string to another piece of memory where we can perform a ASCII to number function block. If we notice below in net 3, we have ASCII to num. Again, this is available from strings. You can convert either a num to an ASCII or an ASCII to a num. Again, in this example, we're trying to obtain a value into a memory integer, so we're going to use ASCII to num. So the first step was to find the location of the two brackets. The next step is to find the length of the information. Now, if I wanted to just go ahead and copy from the value in 630 and 631 to our new string, we would contain a message that included a left bracket. So what we're going to do is subtract, add 1 to 630 and just bump the piece of information over. And again, if we look at our string, we have this location here and this location here. What we need to do is find the address of the first piece of information, and that's 1 to the right of this bracket. Okay. We then subtract the two locations, the bracket and the first piece of information, and we have a length, and we're going to store that in 632. And again, this is just subtract from the math function block. And now we have our string mid function block. We can take a look at this one. Again, starter string is 600. We have our offset and our string length. So our offset, again, is that incremented left bracket. Our string length is the result of the subtraction from the two. And we store it in MI700. Okay. Now once we have our value in MI700, we'll use our ASCII to num function block. And again, this takes the start of the string, the length, and since it's an MI, we're going to go ahead and just call it 6. The largest the value of an MI can be, or the length, is 5, right? Because it's between negative 32,768 and positive 32,767. So in this example, we're really only going to be able to work with MIs. We're going to store that value as an MI here. So in MI7, we'll have the value that was copied in the previous net. And now you also get a parameter which is the factor. And if we contained a decimal point, that would show up in here. In our example, we don't have any decimals. In our, based on our protocol, there's no decimals contained. But if we had a decimal, it would show up here. Okay. So if we take a look at this entire subroutine, if you remember, we had 3 separate pieces of information. Because we're running the subroutine once, we're able to structure it and not worry about looping. So basically what we have here is these 3 nets for the first piece of information, the following 3 for the second, and then the next 3 for the last. Okay. If you notice, we're kind of using this in an indirect manner because we're going to continue to use the same memory locations and the same functions. We're just going to update the information as it goes. Okay. And we can build this in a list instead of using kind of a loop structure. So we've finished converting our number, our ASCII to number, and now we're going to start searching for the next left bracket. Now, one thing that's important to do when we're searching for the next portion of the string is to increment the offset. If we allowed it to start searching from the start of the string, we would find this left bracket again. If we allowed it to start with an offset of the left bracket, it would find the left bracket. So what we want to do is point it to the next portion of the string, and the thing that makes the most sense is to increment based on the right bracket. So we can start searching from the right bracket for the next left bracket, and so we'll find this next portion of the string here. We'll convert that to a string. That'll be our next 3 nets. And following that, we'll do the same again. So we're basically going to reuse this code with the exception of we're changing it from when it's the first start because the first start is 0. Okay, so we'll take a look here. We've incremented our start location, and now we're using the position of the last right bracket to start searching for the next left bracket. So we find the next left bracket, store it in 630 again, find the next right bracket, and now to search for the next right bracket, the start address will be from the left bracket. So we'll continue from here and search for the next right bracket. This is going to let us find the next piece of information in between here. Again, we'll increment the location of the left bracket so we don't include it in our copy. We'll take the length of the bracket in this position to find the, we'll take the position, subtract the position of the 2 to find the length, and then again copy it to MI700, same copy function block, and we'll convert it from an ASCII to a num. Again, same function block with the exception that we've changed the output from memory integer 7 to memory integer 9. Okay, and then we'll do the whole thing again for the third one. We find the next left bracket based on the last position of a right bracket, find the next right bracket after that, subtract to find the length and copy it, and then convert it. Okay, then we're going to update the HMI. So because we've done this in an indirect manner as well, we've been able to kind of reuse a lot of these functions instead of having to write them, and we could just build them in a nice list because our positive subroutine is going to allow us to just run this function, this whole subroutine one time. Yeah, are there any questions on that? I will put a lot more detail in the comments when we put it up online, so you will find a better description of what each specific net is doing. But again, this is a very nice way that we can use these simple tools in kind of a complex manner to just read in basically any length and varying varying length of information from the string we're receiving. Okay. I want to show just a couple more of the string function blocks and how they're useful. Specifically, I want to talk about this RTC to ASCII option we have. I'm going to go ahead and place it here. You notice that RTC, again, is the real-time clock. We have a bunch of predefined options for converting real-time clock information to ASCII string information. Again, this is useful, very useful for data logging when we're logging a string of the current time or date. And again, you'll see this in the data table example. The first options are all on time, different time formats. Hours, minutes, seconds, hours, minutes, AM, PM. The next are date options, different formats. And then finally, you'll notice on the bottom, we have, instead of date, month, year with slashes, we have underscores. Now this is very important because the legal characters we can use for file names are capital letters, lowercase letters, numbers, and the underscore symbol. We talk about a file structure. We don't want to see a slash in the name because it might indicate that it's another directory. In that case, our file name would break the ability for a program to read from a file tree. So we can't include a slash in a file name, but we can include an underscore. So the underscore is what's going to separate our information. If you want the file name of maybe a clone file or the last data table file or CSV to be the month, day, year, you can simply select MDY. Okay. Now notice also that some of these functions have the description following them that gives a little more information about what they are and how you need to store them. Again, strings are stored in a vector. We can't overwrite the middle of this information. Basically, we can't store information in the middle of the string. So we'll look at the time in hours, minutes, seconds. Hours, colon, minutes, colon, seconds is 8 characters. Remember, we have to store a null on the end. This is 9 bytes, or 9 pieces of information. We need to round up, so this is going to be stored in 5 memory integers. I'm going to select this, and now the output is a location to store it to. I'm going to put it into MI900. Okay. But notice if I just hit OK, we're only going to store a description in the MI900. And then we just got through saying that we need to take into account that we need a string with a length, vector of length 5 to store this information. So in order to get rid of this in use and not let our make it very obvious for using these by giving a description, we can select this function, which is the set features for a group of operands. And it's a very nice tool that easily allows us to give a description with a number to this vector. So number operands, we're going to change this to 5. The description, I'm going to change to current time. I'll hit the space, and we'll hit this insert parameter button. And notice we get is a pipe with 3 zeros and a 1. It's going to sequentially number these registers. So MI900 will say current time 1, MI901 will say current time 2, and so on. And just to be a little more precise with the information, we'll hit a space and we'll type of 5. We'll hit OK. And now notice what we've done is we've numbered these sequentially, current time 1 of 5, 2 of 5, 3 of 5, 4 of 5, 5 of 5. And it's very simple to see what this function is doing now, or what these registers are used for, rather. If we just numbered MI900 as current time, we wouldn't be indicating by looking at the descriptions that this is a string or a vector. And we would probably start using MI901 and 902. It would cause a lot of problems. And this is true for all vector and all string functions. You absolutely need to store a description to all the pieces of information that are going to be used in the vector. Now that we've added that, let's go to our memory field. If we want to add a new entry, we can click here and type in 900. Notice that the length is left blank. We do have to type something in. 32 is the max length, and since this function for ASCII strings is going to read to null, there's nothing wrong with typing that in. Okay. So let me download this, and we'll take a quick look at it. Okay, it's finished. We'll go online and we'll select memory. And notice that the time is currently counting away as an ASCII string here. So very, very simple way to convert a piece of useful information like the current time into an ASCII string. If we wanted to use this as a timestamp, we can, in our indirect email body, use this piece of information. Now, along the same lines, there's a function called IP to ASCII. If you need to get the IP address or the MAC address as well of the controller, you can send it in an email to whoever would need to see it. Some pieces of information we didn't look at: remove string. We can remove a character from a string. And we also have a replace string, which will allow us to replace a piece of information. So maybe we have built a string that does contain slashes. If we want to replace the slashes and make them underscores, we can use this function to do that. Okay, so are there any other questions? I think we've gone through quite a bit in VisiLogic. We did start with some simpler functions, and then we showed a more advanced function with the parse input and the receive of the scan to show how we can use these tools together. Okay. Again, other relevant webinars we have are the data table webinar and the function block protocol webinar and the SD card webinar. In the SD card example, we show how to build file names from the SD card, for the SD card files, the CSV and the data table files. Again, ASCII strings are very useful for communications options, and we saw that with the protocol send. Okay, so there's a question about using the string libraries. We don't have anything set up in the string library here. Let me go ahead and just pull one down. I will just make a quick string library entry. Won't discuss it very much, but I'll put hello in string library 1. I'm sorry, string entry 0. And in string entry 1, we'll say bye. Okay, so if we are using the string library and we are either using it to have the ability to pass the same strings between two applications, or we're using it for foreign language support, we can indirectly select the strings, and we can copy them to memory integers as ASCII strings. And if we wanted to say log information from the alarms to the data table, all the alarm descriptions are saved in the string library. If we wanted to pull them out, we can use the string library string to ASCII. We would select the string ID. In this case, we can put a 0 or a 1. The length, again, we'll call it 30 just to make sure we have enough space. We'll put this in 1000. We'll give it a description. Okay. And the status, of course. Now we run this function block, we'll pull the string out of the string library, and we'll save it as a string in the system. Did that answer your question, Mark? Okay, there's another question about RTC and daylight savings time. There is an example. If we go into the examples folder, under okay, I'm sorry, I don't know the location. In the examples folder, there is a daylight savings example which will add an hour or subtract an hour at the appropriate time of the year. Doing this will update the RTC, and so whatever we pull out from the ASCII, the RTC to string function will be updated based on the RTC in the system. Okay. Are there any other questions? No? Okay. Thank you for coming. Again, this will be recorded, and this example program will be available on our website for download. We will be having more webinars coming up. I believe we'll be doing one on SMS coming up, one on UD licensing, and one on the Jazz. So do look at your email for the invitations to these next ones. Again, if you have examples that you'd like to see, if you have topics you'd like to see covered, or really anything else, comments, feedback, please send them to us at support@unitronics.com. We really are trying to start ramping up our library again and doing presentations either once or twice a month. Again, thank you, and Happy New Year for everyone. This is the start of 2012. All right, thank you. Have a great day.